So let's continue with my discussion of wiring the MicroLogix1000 analog. The first thing I'm going to do is talk about the first thing you should always do when wiring up a PLC, which is to wire in the power and the ground. The power for these Allen Bradley PLCs is always on the bottom left, and here it marks clearly what this PLC needs in terms of power. It needs a 24-volt DC plus on the left little screw here and minus on the right little screw. That means the differential should be plus 24 and minus 24. The second thing it needs is a ground wire. Very, very important that we have a ground wire in the PLC. I'm going to draw a little line around the PLC so that we can talk about this and show where the wiring will actually go. The second thing we're going to talk about is wiring up inputs. The input rail, like I said, is on the top. This particular PLC has got two little screws, lugs that are used, that are not used. They're marked not used, and that's because we don't use them on this particular model. We might on some other models. For an AC, for instance, version of this particular PLC, you might use those lugs. But for a DC common analog input version, we don't need those two lugs. So what we do have here is a DC common and then a group of inputs associated with that common. We know they're associated because we've got a little line that touches them all together. Now, what that means is that we need to have energy flow through this PLC for this PLC to sense whether an input is on or not. So there's two ways I can have energy flow through the PLC. I can put a plus 24 on my DC common and then have a minus 24 connected to any one of these 3 or 4 inputs. And that energy will now flow from the plus to the minus and cause my input to turn on. If my input is hooked through a switch or through a sensor, then that sensor turning on would hook up that minus, and then that would let that energy flow through the sensor and turn on that input. I could also hook up a minus on DC comm, and the plus side would then come from the sensor or the switch. And when there was a plus 24 voltage appearing on any one of these lugs, then that plus energy would flow through the PLC out the DC comm, and then that flow through would cause that input to turn on in that direction. This PLC can be wired up in either direction. And frankly, depending on which sensors you use, you might need to wire it up either way, because some sensors require energy to flow through the sensor, from the sensor, or through the sensor to the sensor. And that's an NPN and PNP sensor. We're going to get into that in the next class. Don't worry about it. But just understand you have to have energy flowing through the sensor to make that work. The last thing we're going to talk about is outputs. Actually, the second to last thing. We're going to talk about analog stuff in a minute too. Outputs also have a common. And like I said in our earlier classes, don't get confused between what these commons mean. A DC common for an input is purely associated with just those inputs. It's not associated with what a white wire in an AC circuit. It is simply the common wire allowing energy to flow through the inputs. The same thing for the output common. I would apply 120 volts here or 24 volts DC here. Anything I want here, and when that output is programmed to turn on, when the internal program, your ladder logic tells that output to turn on, it throws a little switch inside the PLC, and then now your output lug will become hot. And that either 24 volt hot or 110 volt hot or whatever voltage you applied in here, it would allow that energy to flow through there. How much energy can flow through depends on the specifications of the PLC. Generally, these smaller PLCs can only handle between 3 and 5 amps. So you want to have a maximum about probably 3 amps in general, I think 5 amps max. And that energy can then flow through there. Now notice that someone put X's above in output 0. Why are there X's above that? That's because they cooked that output. They put more than 5 amps through that output, so they cooked this particular PLC output. Now the rest of the PLC works, but output 0 can't be used anymore. So if you end up using this particular PLC, you'll just have to move any of the documented output 0 program items over to the next output along. We also have output 1 gets its own common, and then outputs 2 and 3 get a shared common, and then outputs 4 through 7 get a shared common. A common output means that's the wire you hook up to create output energy once that internal switch is thrown by the program to these various output terminals.